What's up, everybody? Let's talk tank safety, air gun safety, filling your tank. I'm going to go over like 4 different areas that can help make things a little bit safer. Now, I do have some graphic video I'd like to share with you guys on PSI and what happens and some of the stuff. So my first interaction with filling tanks was probably about 20 years ago, and went to a scuba shop, and I kind of felt like you'll see in this next clip.
Damn it, Martin! This is compressed air. Well, what the hell kind of a knot was that? You pulled the wrong one! You screw around with these tanks and they're gonna blow up!
I kind of felt like that would happen as far as messing around with compressed air. You're gonna get some huge explosion or something like that. And so maybe not quite that big of an explosion, but in some of this next video, we're gonna look at what happens when you actually shoot some of these tanks, a couple different videos on that. But before we get into that, there is the first one, and that's the explosion of a guy shooting a 50 cal Turkish rifle for the very first time. And I guess this bolt action is notorious for not being the best, I guess, quality, and we'll take a look. So I guess the guy lived through that. The bolt actually came out the back. It's about 65,000 PSI, which is an insane amount of power. As you know, a lot of regular rifles, if they load them too hot, you know, the gunpowder stuff, if they load it too hot, you can get explosions, barrels blowing up and everything else. But that kind of makes me a little bit uneasy dealing with some of these tanks, because as we noticed when I first got into the industry, you had maybe 2,000 PSI, and then the Air Force Condors raised it up to 3,000 PSI, and then we went to 250 bar, and now the Vulcans do 300 bar, and I think the Human K1s will do up to 5,000 PSI. And so most of these tanks are rated at, you know, 2 to 3 times the fill pressure, so, you know, maybe 7,000, 8,000 PSI. But there's some things to kind of take into consideration. But the question is, how big a boom does it make? Like, what can you expect if one of these kind of goes full out nuke and erupts around you? So in the first video, take a look at this paintballing session. This is, you know, about 25 years ago. Used to do a little bit of paintball. They use HPA for a lot of this stuff, high pressure air, but it's not around the 4,000 PSI. It's more along the 1,600 PSI. And check out what happens when you get a breach on an air gun, or I should say a marker, while they're out in the field. Okay, as you can see moving through this, the tank breaks at the neck when the individual lands on it. It kind of knocks him out, and if you watch the tank flip around on the paintball field, it hits another individual probably like 10 yards away in the ankle. Initially, this guy doesn't feel it because he's in the zone fighting in this little paintball war. But once things get done, he starts limping and he goes down holding his ankle. So I'm pretty sure it broke his ankle on this. And yeah, it just shows you that's probably only 1,600 PSI, maybe 2,000 PSI on like a mid-sized small tank. But if we go to another video, I'll show you where Plinksters, you guys know Plinksters 22, if you look at him, he actually takes a Air Force Texan like 50 cal and shoots a 3,000, 4,000 PSI tank. It actually doesn't blow up. And then he actually uses a 308 to kind of puncture that. So that did surprise me at how, I guess, solid these tanks are to be able to kind of ward off, you know, a little misfire. Because I was always wondering if someone punctured one of these tanks with an air gun, if it was possible, if it would just explode or what happens. But if you kind of watch this video, this is a common theme.
Holy cow!
Okay, as you notice this, the air comes out, it ruptures out of one point, and then it just goes haywire like a missile. And if you check out this another video, you'll see the same thing.
Oh.
And if you watch another video, you'll see the same thing. When the bullet or whatever punctures the actual tank, it takes off like a missile. And so we got kind of 4 areas. We can use this knowledge to kind of make some things that are a little bit safer. And so for the general inspection, before we get to actually fill up the tank, because that's the main thing that worries me, is filling up big tanks to 4,500 PSI. So you'll notice the actual neck here. So inspecting the tank, you kind of want to look at the born on date. And I think this is carbon fiber. It needs to be hydroteched, I think every 5 years. But before you even fill it, you just want to look at the date and then kind of inspect the tank, see if you see any big ruptures or anything. And my understanding, if these tanks fail, it's usually in the neck or the threads. Now there's a couple different failures that I've seen or heard about. One is this kind of screws in and it has threads. These get blown out in an overfill. So essentially this becomes like a missile going this way. But the other one is I look around the neck and you kind of want to see if there's any cracks there. These seem to be the 2 most prominent places these tanks break. And so you're looking at that looks actually pretty good. We can kind of use this knowledge when we start to fill up the tank. The other thing we want to make sure of is using compressed air. Now there's a lot of clowns out there that will try to use helium, pure oxygen. Some people can get compressed air, oxygen from a hospital. All that stuff's like flammable, insane to use. Just use compressed air, nitrogen, something very safe for that. Next step is, before you even get into this and you want to look at what you're going to use, the next step is to make sure that you have a water filtration device on your compressor. Now this is something I've talked about in the past, the really cheap compressors that might not remove all the water, but there's other things that can get in, and that's oil or anything flammable would be horrendous inside this tank. As you can see, it might add to the explosive nature or just corrode the inside of the tank to make it weaker. So I'm starting to rethink my opinion on cheap air compressors, just simply from the fact that even my $2,000 compressor, when it pushes the water out the water ejection area, there's a little taint of oil and there's a little taint of just a little different smell of some kind of chemicals. And I kind of wonder how much is actually getting in the tank and how much it filters that out. Lastly, before we fill up our tank, we need to kind of check the auto safety device on your compressors. And there's kind of like a dongle or a fill port that you can just kind of cap it off. And what you want to do, instead of filling your tank up 100%, you just turn on the compressor and let it fill up the hose or the line to 4,500 PSI to make sure it shuts off on time. Now you can do this a couple different ways. You could plug in your tank and just not open the valve to have it fill up. So again, it just fills the hose from the compressor to this hose up to 4,500 PSI, and you know that when you're waiting for it to shut down and everything works. Okay, let's talk about safety in filling the tank. First thing is you definitely want to get eye protection. Ear protections, it's up to you. Where the ear protection comes in is if there's a breach, not necessarily in the tank, but a lot of times if you have something like 3,000, 4,000 PSI, the hose can start expanding, and when it blows, it's like a super freaking loud balloon. Believe it or not, it is like an M80 going off. So just to know, if you want to play around with that kind of stuff, that's fine, but eye protection to me is a must. So a lot of times when I fill my tank out in the garage, I put it in my paintball bag, as you guys have seen before. That kind of weighs it down and gives me a little bit of protection in filling up the tank, especially that 98 cubic foot tank. The other thing is I make note of is when we see these have a breach, wherever the breach is at, usually it becomes like a missile going this way. So I'm very cognizant when I fill up the tank is to look to where this is pointing. I don't have it point at me. If I'm doing anything, I just kind of put it and maybe put the backside up against a wall, put it in my bag. That way it doesn't become a missile, or if it's going to get pointed, it's somewhere away from me and this part is away. Just don't get in the line of fire if something is to break open or some kind of breach. As I'm filling up the tank, I usually don't go up to 4,500 PSI. As I mentioned, these tanks are already kind of tested up to 7,000 PSI, but I usually use 4,350. And the reason why is because if it's a summer day and you're out in the field and it sits in the sun, your tank gets warm. and heat expands, your air pressure in your tank goes up. It will easily exceed 4,500 psi. If you're filling your tank in the garage at 80 degrees and it's not sunny, you go out on a 100-degree day, put it in the sun, you'll easily be way over 4,500 by the time you're done. And lastly, I let the actual tank sit. So once my compressor goes off, or I set it at 4,300, 4,350 psi, I just kind of let it sit, and I'll close the tank valve and just let it sit for a little bit before it takes me 2 or 3 minutes to degas my compressor, because there's a water exchange valve that you have to turn on. You have to be around the tank, but just for me and my safety procedures, I just kind of like to sit there, let it sit for 10 minutes after it's at 4,300 psi. If nothing happens, it'll take me a minute or two to hang over the tank to degas it and to get the water out, and then I move the tank and my bag to a safe spot. All right, guys, let's talk about transporting your tanks. This is one thing. I put the tank in the trunk. I don't put it right behind me, because if there is a breach and you're driving down the highway, dude, you are going to be missing some eardrums. It's just going to annihilate, be like a little hand grenade going off in your car. So it's best to be in the trunk. The other thing, in the trunk, I never leave my tanks in a car for very long, whether it's super cold or super hot, especially when it's super hot, because your car can get up to 160, 170 degrees depending on that, especially if you have your tank in the sun. To me, you're just kind of asking for trouble when you have those huge swings in temperature. Things happen. Seals blow, rubber gets soft, it starts to melt at 180 degrees in your car, and you're just asking for a lot of issues. The other thing I do is I don't transfer a super cold tank that's been out in the field into a warm house, because you get condensation all over it. So I put it in a staging area, generally leave it in the garage, which is kind of like a lukewarm 30 to 40 degrees. But if it's been in minus 30 degrees and you move it into something like 30 or 40 degrees, that's a big swing, but it's kind of rough on the composition of the tank if you go from like minus 30 to 70 degrees within just a few minutes. I wouldn't suggest that. And lastly, storing the tank overall for long term. Most of the time I have this in the garage in kind of like a corner. Again, with the projectile end, take in mind where you want this if it's to blow up. I have some in my basement, obviously well away from people, just in case something happens. So you're probably wondering, I feel like I'm overly protective or overly sensitive. And yes, I try to be as safe as possible, but I will say this. I've had tanks actually kind of degas and explode on me. This here just blew a seal a couple days ago, and it was super loud. I was upstairs and it just, bam, it just blew off, and I was like, oh, that's a gun or that's a rifle. And sometimes you'll have something in your rifle that actually kind of blows apart, and it's quite loud. So stuff happens, guys. You just kind of know that. Try to be as safe as possible. But again, I'm always very cautious about this. To me, has my air gunning improved all that much, or has it become a lot funner if I use 5,000 psi versus 1,500 psi? No, it's not like 4 times better, 3 times better. Yeah, you can do some better things with this high pressure, but I kind of like the low end of the pressure spectrum, just seeing what happens to rifles. There's been things out there, as you guys see on Airgun Nation, where some guns have kind of blown up, and there's a lot of investigation. And to me, I just don't want to push an air gun with super high pressure to the max. I'd rather just have something like a 10-time variable built-in safety solution versus 2. But I kind of want to know what your guys did. I miss anything with safety and filling up air tanks and the overall general things? Write it down, comments, questions. See you guys next week.